Hi, if you follow my Twitter handle at all, which is at Xiotex, Xiotex, you'll know that I'm mostly going over about Nando's chicken or shaders, and for quite a while now I've been promising quite a few people that I would do a tutorial in how I create shaders within Unity. So here it is, okay? But first things first, we have to know what are shaders, why should you care about them, and then we'll move on to how to actually create them and how to use them, okay? So there's no really easy way of describing shaders without getting a bit too technical, okay? But here we go, I'll try and do my best. So you've created your amazing game in Unity, and imagine there's a screen there, and you know, it's drawing lots of things. So I don't know, little car, there you are, amazing art for a car on the window and stuff like that. Okay, now say this is a 2D image, okay, or even a 3D, it doesn't matter. When it comes to be drawing that image or that 3D object within the graphics card, all that information there gets decomposed down into triangles. If it's a 2D image, it'll look like this, most likely. 2 triangles. If it's a 3D object, say, I don't know, for simplicity, a cube. There'll be 2 triangles there, 2 triangles there, and 2 triangles there. You get the message here, okay? So everything's made up of triangles, unless you're drawing a point or a line, of course. These 2 things don't involve triangles unless that's a thick line, but that's get a bit too complicated. But the point is, whenever you draw absolutely anything, render absolutely anything in Unity, be it 2D or 3D, at some point in the line down in the graphics card is saying, that's a triangle, I'll draw a triangle. Even that triangle's a little texture applied to it, okay? It all comes down to triangles. So, let's go to the most basic level. So if we get a triangle, if you remember your school, a triangle is made up of 3 points. Now, it may not seem intuitive to draw by triangles, but the thing is, that's the way graphics card operates, and it's something, you know, just you can either accept that or not, but it's how it works, okay? That triangle can have an image applied to it, or can have a color applied to it, doesn't matter. So you know, your pit of your dog might be down, or your car might be here, in there. But the point is, it's a triangle, okay? Let's get rid of those. And as I said, a triangle is made up of 3 points. Let's call those A, B, and C. Now, in computer graphics jargon, we call each one of these a vertex. And collectively, they're known as vertices. Okay, so all 3 of those put together become vertices, but each one is just a vertex, okay? And all these vertex do is just to find a point in space, okay? It's either 2D, it'll be X, Y, as you remember. In 3D, there'll be an extra one, Z, okay? So each one of these vertex has X, Y, and Z, plus one other which we'll cover later. We don't need to know about that right now, okay? Now the thing is, the graphics card, okay, so when you go use your screen with stuff on it, see, there's our object, whatever that is, 2D or 3D, it goes down to the graphics card, say, go on, draw it for me. And the graphics card, which we call the GPU, goes, okay then, I'll take that information, these bunch of triangles you're supplying me, and I'll draw them. But in order to draw them, I'm going to pass them straight through to 2 things first, okay? The first one being a Vertex Shader, which takes these vertices, does stuff to them, and gets it into a format ready for the next stage, which is the Fragment Shader. Fragment Shader goes, okay, I've taken those points, and if you've supplied me with a texture, I will now apply that texture to that triangle. So you can draw your car, or part of it. The next part would be in the next triangle that comes down, forming your entire shape, or your 3D object, okay? And then finally it does some other stuff, and then what you get is the screen and output, okay? That's a very grossly simplified view of what goes on, but it's all we really need to know in order to do the shaders. The shaders part is us creating these two bits here. So, like when you do C# or JavaScript, you're supplying code for the CPU, which sits over here. We're now going to supply code for the GPU and tell it what to do when drawing our stuff. Because beyond the basic stuff, we can do some really funky things with shaders. Stuff that you wouldn't imagine. Special effects, we can do procedural animation, we can do lots of things. But for now, we're going to do something very simple, which is just to colour something on screen. And to do that, we're going to go to Unity. So, here's Unity. I've already got a very basic camera set up, positioned at 0, 10, and 0, so x0, y10, z0. Angle it at 90 degrees on x. I'm pointing down. The reason I'm pointing down is because I want to apply a shader to a very basic object, and in this case I'm going to use a plane. If we look, there we go, in the camera preview, or if I run it, there's our plane. Now, as already mentioned, it looks like a square, but that square is actually made up of triangles. Now, Unity's, when it creates plane, actually creates lots of triangles to create this one thing, but just imagine, for our cases here, it's just two triangles put together to form a square. Okay, so it doesn't have to get any more complicated than that. Now, as you can see, this is looking very dull, very unexciting. So we're gonna apply something else to it. We're gonna apply a shader. Now, in order to do that, we need to apply a material. So we go to the plane. We see here the mesh renderer. Oh, let's turn these off. We don't want shadows. We don't want to receive shadows. It's not actually going to use those, but I like to turn them off anyway. And we got materials. And currently it's got the default diffuse material, which doesn't do much. So we want to create a new material. So let's do that. Let's go to Assets, Create, Material. Let's call it a basic, if I can spell, shader material. Let's go to the plane and let's drag that over there. So now we've replaced the default diffuse material with our basic shader material, and inside there, as you can see, there's a new thing popped up in the inspector saying basic shader material, shader. What shader are we using? We're using the diffuse shader. And if you click on that, you'll find all the different shaders you can use. If we go to decal shader, we get new boxes up here, and each one of those allows us to set textures that the shader will use. Okay, but these are the built-in shaders, and you can use them if you want to, and most of the time you'll get away with just using those things. It won't really matter. It doesn't really affect it. It just means that, you know, every game you make, if you're using the default built-in stuff, will look like any other game made with the built-in default stuff, other than new textures and so forth. So what we're going to show you here is how to create a custom shader, or at least try to anyway. So shaders live within materials, as you can see here. Okay, and these stuff here is all derived from the information the shader supplies. Just Unity's way of exposing it. Now the thing is, I'm using Unity here, but shaders apply whether you're writing native code for iOS, native code for DirectX, whatever version 9, 11, 10, or even OpenGL with GLSL. The shaders themselves, the principles are the same, the form will be a little bit different. I'm using Unity because you can get the free version of Unity, and you know, it's the most accessible version for you all to learn this stuff with. And most of the people I'm noticing are Unity users anyway. So anyway, let's go ahead, let's create our shader. To do that, go to Create, and look, menu option, shader. It's almost as if the Unity guys knew you want to create them and just gave us that option. Shocking. Anyway, let's name it Basic, God, I can't learn to type, shader. Let Unity think about that for a second. There you go. And if we open that up, oh, reload, there you go. It's created a default basic shader for us. Now we can go straight into Unity, into the material, drag that from there to there, and there we go. This shader is now called Custom Basic Shader. If we go to the plane, you can see it's still in the plane, and it's called Basic Shader Material with a shader of Basic Shader. It's all there, but we want to change that shader. So let's double click on that again, take it in there. Now I'm using Sublime Text 2. If you're using Unity the first time, you might be using Modern Develop. It doesn't matter what your crate is in, it's just a text file at the end of the day, okay? So I'm going to tidy this up a bit because I don't like the formatting it does. And that banging you can hear in the background is my newly repaired office chair. It's ancient, but I'm keeping it living. So, let's save that for a second. So this default shader it's created is a surface shader. Now let's go back to the sketch. Now this stuff here, Unity quite rightly thought, well, this is all a bit complicated. You really don't need to know absolutely everything in there to get the most basic stuff done in shaders. There is a lot of that can be handled for you. And in fact, they did that. So let's get rid of this. The pipeline they created is, so you imagine screen with your image, goes down to, well, in this case, rather than the GPU, it's via Unity to a surface shader, which then goes down to GPU, and then all the stuff we had before. Okay, but this bit here is Unity's attempt to make shaders a lot simpler to create, and they did quite a good job on that. I don't tend to use the surface shaders because when it generates the code, it's including a lot of instructions that aren't quite good for some of the other platforms like iOS. But you know, your difference, your mileage may vary, so it's up to you what you use. For this tutorial, I'm going to cover non-surface shaders. So we're going to get rid of a lot of this stuff. So we can get rid of that. Don't really need the LOD, but I'll leave it in there anyway. We're not going to use a texture for now, okay? So properties. When we saw the shader in Unity before, and up here, that stuff there, base RGB, that actually is derived from the properties section here. So see base RGB? All it's saying is this shader is going to use a texture. This is what you need to display in the inspector. But for now, we don't need that. We're going to remove it. We're also going to introduce one more thing, which is a pass. I do this for completeness. You don't really need it, but I like to do it. So let me just indent that stuff. So this is a bare bones shader. There's not much in it at all. In fact, there's nothing in it. Okay, so at the topmost level, we're defining a shader. We're calling it in the custom field. It's a basic shader, the one we named it. Properties, as we've already mentioned, this is stuff to be displayed in the inspector, and also stuff that's available to the shader you use. Okay, so textures, variables like floating point numbers, sliders, the whole lot. You can do lots in there, but we won't go through them right now because we don't need to. Inside this shader is a sub-shader. This stuff here just tells Unity which render pipeline to use, or render queue, sorry. So we're saying this is an opaque object. It won't have alpha, so draw it in the opaque stage. So if you don't have any transparency, and it's going to draw it in that stage. LOD 200 is, you don't need to really worry about that for now. And inside this shader, we've got a single pass. We can define multiple passes, so a single shader can draw multiple times, depending on what you want to do. But we don't need to do that here. And this one, we're going to use a CG program. Now, back in the day, in the big graphics card battles between ATI and NVIDIA, and with vendors like DirectX and OpenGL, different flavors of language appeared for writing shaders in. The most basic low-level one was like an assembler type language. We're not going to do that here. And the next one was high-level languages. So for DirectX you had HLSL, which is high-level shader language. OpenGL we had GLSL. But an outlier, NVIDIA, decided to create their own called CG, which is the one that Unity seemed to have adopted. It's okay. There's no real difference between them. There's slight syntax variations, but for the most part, a shader written in CG will look pretty much like a shader written in GLSL or shader written in HLSL. There's just some slight changes. You don't really need to worry about them. Unity always throws in this one, okay, when you do a shader. I always include it. If I spelled that right. D3D11. And all we're saying in there is we want to exclude particular render set. Okay, so when you create a shader, you can actually target different types of platforms. So this pass, I'm saying I don't want it to be D3D11. I want it to use CG. So we're going to use the OpenGL pipeline. You can also exclude things like the Xbox 360. So you don't try and target those platforms, because if you do and you use instructions those platforms don't have, you will get errors. CG pretty much applies to all of them, so you can use the CG on a PC, Mac, iOS. It's easy, okay? And next we have to tell the shader compiler that we're going to use a Vertex Shader. And that's how you do this. So we're now telling the Vertex compiler, which is going to take all this code and tell it that we're using a Vertex Shader and this is what it's going to be called. It's going to be called Vertex Shader. Next one, we have to tell it we're going to use a Fragment Shader. There you go. So now we've defined a Vertex Shader and a Fragment Shader. Now I've called them Vertex underscore Shader and Fragment underscore Shader, but that's just the names I've given them for completeness. They could be called anything, okay? The next thing is to let Unity do some neat stuff for us by including some pre-built code. And that's just going to import quite a lot of useful functions. We're going to use a couple of them here, or macros as well. We're going to use a couple here, but for the most part you can ignore it. And if you want to, when you get more advanced, you'll dig into that file to see what it's providing. Now, as you can see, we've already got a program errors at line 17. What's all that about? So you go into there and say, oh, well, there's nothing in there. Failed to find entry function Vertex Shader. It's because we haven't actually defined it yet. We've only given it a name. And let's go define that now. Now, as I said, a Vertex Shader takes the vertices and does stuffing to them, okay? It's going to output something to the Fragment Shader to use, but we have to tell it what to output, and we can do that by defining a struct, okay? So we're going to call it v2f. That's usually, you'll find as a default. And we're going to say, we're going to output a float4. We're going to call it pos. And it's going to be of type sv position. Now, if you remember earlier, I said that a vertex, a single point, let's go in here, let's go back to our triangle. This here is composed of x, y, and z. Those are 3 points, but as you can see here, I'm defining an output of 4 points, four floats. What's all that about? Well, as it turns out, there's an extra one in the end called w. Now again, for the purpose of this tutorial, you don't really need to worry about what that w is. Just know that it's there. So whenever we pass through any vertices within a vertex or a fragment shader, there are always 4 floats in there. X, Y, and Z. Okay? Now if you're doing a 2D game, most of the time you're just dealing with those two there. You can pretty much ignore Z and W. But if you're doing a 3D game, then chances are you're using X, Y, and Z. Okay? It doesn't matter which one you use, okay? When it comes down, it always comes down as X, Y, Z, and W. So, that's our structure, nearly complete. There you go. Save that. Let's go back to Unity, watch the compile errors. Okay, now we have to actually define the vertex shader, which we called vertex shader here. So it's going to output our structure, v2f. It's going to take an input of app data underscore base. We'll call that v. This little magic structure here is actually defined in Unity cg.cg inc. Okay, and it contains a lot of information, but the most important one for us at the moment is those four floats coming down, which define a vertex position. Okay. So the next stage is to define our output. So this looks like, you know, any code you've written before. It's no different really from C. It's just it's not as complex, okay, or C# or JavaScript, okay. So we define an output, our output there, v2f_o, and we say o.pos. So we define pos here is equal to, there we go, Unity matrix mvp.v.vertex. Now this is pretty much a macro which is imported from here, well, sorry, in there. And all we're doing is we're saying, take this vertex coming down from your code and do some magic stuff to it to translate it, so to transform it so it appears on the screen. Now, if we go back to Unity for a second, that plane, which I position at 0, actually, let's position that at 0, shall we? There we go. 0, 0, 0, with a rotation of 0, 0, 0, and a scale of 1, 1, 1. Well, all that information affects where our plane appears on the screen. That information has to be transformed using the vertices. Each one of those vertices has to be transformed using that information to provide the final output. And this is the line that magically does that. Okay? It doesn't get any harder than that. You can do things to make it harder than that if you want to, but for most of the time that's all you need. And now we'll just say return O. And that, in a nutshell, is our Vertex Shader. Now, hopefully at some point those errors will go away once we complete this. It's the part I always hate. So, we've defined the Vertex Shader, now we have to define the Fragment Shader. And to do that, we go float 4. Now, as I mentioned before, the Vertex Shader, let's get rid of this again. Vertex Shader works on points or vertices. The Fragment Shader is the code that draws all the pixels inside those points. So its output is a color. The color to color each one of those little pixels. You know, green, whatever. And colors are defined as floats. And in our case, 4 floats. Why 4 floats? Well, we've got red, green, blue, and alpha. So alpha controls how translucent something is, and RGB controls the actual color. So when we do the output from a fragment shader, it's a float 4 to say, here's a bit of code I'm going to execute, and the result you're going to get from this is 4 floats, which represents the color and the alpha for this particular pixel. So let's give that name. So Fragment Shader. So again, it looks just like a function you write in JavaScript or C#, nothing more complicated. We're taking in a v2f, which we're passing out from here. So remember, the data goes from CPU to GPU. This goes into our Vertex Shader, which then passes straight into our Fragment Shader to eventually go into the screen. Okay, so our Vertex Shader is passing information into the Fragment Shader, which is then passing information there. So the stuff we're getting into here is our v2f, and the stuff we're getting out of here is our float 4. Okay, so we're passing the v2f into the Fragment Shader, and the float 4 out of the Fragment Shader into the final stage, which is hopefully going to be the screen or whatever. Okay. So v2f, I'm going to give that I, really descriptive name, input. But I'm also going to give the output a bit of context information. In this case, it's going to be we're outputting a color. And then in there, we'll just do something very simple. We're going to return a float 4. Now it was grey on the screen before, so let's give it a different colour. Let's give it red 0, 1 green, 0 for blue, and 1 for alpha, so make sure we can see it. And hopefully Unity isn't going to say they've got any more errors. Yay. Okay, it says unrecognized renderer for the Pragma exclude renderers Xbox 360 line 16, but that should be fine. Oh, and there we go. It's green. If we look at our plane, because we applied shaded before, notice that there's nothing inside there now. It has no textures, it's just going, it's green. If I run the code, there we go. Our plane, which was a dull grey before, is now magically a green. So what happened there? What have we done? So in the code, as we see here before, we've got the Vertex Shader coming in, transform position, so it converts the what we call local space into world space, eventually into screen space. Okay, so don't worry about that. All it means is just use that line and stuff will magically happen that gets your stuff in the where you want it to be. Okay. The fragment shader is where we're going to do the fun part. So we're saying here, okay, we're outputting a float 4, which is the color for every single pixel within those triangles. We're taking the input from the Vertex Shader code here, so we know where to put it. And we're just going to output a color. So in this case, I'm outputting a flat color. Now the color, as I said, is R, G, and B, but each of those components is 0 to 1 for R, 0 to 1 for green, 0 to 1 for B, and 0 to 1 for A, okay? So any color you do is 0 to 1. So if we wanted to change that, let's make, I don't know, let's make it purple. Actually, let's not make it purple, let's make it yellow. Hopefully that's yellow. Oh look, yep, it's yellow. And it's turned yellow. That's it. And that is the most basic shader. So what we've done there, we've taken all the vertices for all those triangles, we've done some stuff to them to convert them, and we've coloured every single pixel within those triangles yellow at this point in time. But the thing is, at this point in time, you're looking at this and saying, well, how does that prove that every single pixel within there is actually being coloured something? Well, let's show that in action now. You can supply extra information, okay? So whenever you apply a texture to something in Unity, or any kind of graphics card really. Let's go back to black. So let's imagine our square again, made up of triangle. So let's say within our image we've got our very basic car again. That's our image, that's the texture we apply, okay? So we've got our points, our vertices. Each vertex has got X, Y, Z, and that W. It also has an extra bit of information called U and V. I know my U's are a bit like my V's, but so each one of these has got X, Y, Z, W, also U and V. Those UV coordinates, as they're called, are two floats, and they define where on these triangles is the actual texture. Okay? And those are mapped from 0 to 1 again. So U and V. And all we're saying is U, in this case, is horizontal, V is vertical. So if you imagine you've got a huge texture, and somewhere in that texture is your car, and there might be a, I don't know, something else over here. You're just saying for this particular quad, or square, we're going to position it so it takes out that texture there. UV coordinates, let's go up there, so that's U, there, V. Same for here. Same for down there always. Okay, so UV. So in this case, we're going to say the default. So in Unity we've created this plane, which we've got. If we show here again, let's run it. And we're going to say, we're going to take whatever the defaults. Now it happens that Unity just maps the entire texture to the base of this. So that'll be 0 U, 0 V, 1 U, 0 V, 0 U, V, 1, and 1, 1. So what we end up with is this for our plane. This is what Unity supplied. So again, X, Y, Z, W, but the U is going to be equal to 0, V is going to equal 0, same for here, X and Y, Z, but this time U is going to be 1, V is going to be 0. Down here it's going to be U is equal to 0, V is equal to 1, U is equal to 1, V is equal to 1. Okay, so all we're saying is map the pixels from 0 to 1 along there and all go down. Okay, so we're going to take those and turn them into colours so you can see exactly what goes on there and show a little bit the magic of shaders. So to do that, we pass the information from our Vertex Shader into the Fragment Shader, and to do that we do float to 2 because U and V, two floats, call it UV, and this type is of text chord 0. You can have multiple texture coordinates, which is where the power of shaders come into really playing, but in this case we're only use one. And we're not going to do anything special to it, we're literally just going to pass it straight through, taking it from V. Now V, app database, comes with this text code already passed through. We're going to pass it straight through to our fragment shader, and inside our fragment shader we're going to do uv.x and then uv.y. So that's a float 2. We reference those x and y, not u and v, okay? Everything in a float is going to be x, y, z, or w. So a float 4 would look like x, y, z, w. A float 2 would look like x, y. A float 3, if we were to do it, would be x, y, z. I think you get the idea. Anyway, now I'm just going to make this simple again, get rid of the clutter. So what we're saying is we've got UV coordinates, which are float 2, which are type text code. We're going to pass them straight from app database V, which is the incoming vertex, straight through to our structure and straight into our fragment shader. And we're going to pass them straight into our float. We're going to take the X component of the float 2, pass it in as red. We're going to take the Y component of the float 2 and pass it as the green component. And let's see what happens. Absolutely nothing, which means I've broken it somehow. This is the magic. So if you see stuff that's gone wrong, it's all to do with this, okay? And so, because I did this deliberately, I didn't really do it deliberately, but this is an example of where stuff can go wrong. So it's saying UV undeclared identifier at 16, and the reason being is because I didn't say where am I getting from. In this case, I'm getting it from the input, so it should be I dot. There you go. So we're saying the incoming structure inside there, which is a V2F, is a UV field. Take that, take the X, take the Y, and look, magically Unity's going, I can understand that. So let's run it. What did that do? There we go. So this proves, okay, so 0, 0, 0, 1, 0, 1, 1, 0, sorry, and 1, 1. In fact, did I get that diagram right? Yeah, I did. Okay, 1, 0. That's cool. So for every single pixel within those triangles, I'm going to take that u.x or u and apply it to red, take the v, apply it to green. So we're going from over here, we're getting the mixture of the colours and so forth, and all the way down for each one of those coordinates. So that shows you every single pixel is being filled in, and we're giving it coordinate colours, which is what we did there. Nothing more magical than that. But that's useful for doing some basic stuff like just colouring every single colour within the triangles. But what if we want to do a bit more than that? Let's make this thing move around a bit. Okay, so let's go. I don't know. Let's create a new float 4 because we're going to do something with this and call it pos. And we're going to set it to the incoming vertex. And I'm going to do something with this now. Okay. Let's change this now. So instead of taking straight the incoming vertex, we'll set it to pos up here, which we just set, and we're going to do some magical stuff to it. So let's make pos.x. Let's make the x coordinate move around a bit. So we're going to just do a bit of math on this. We're going to use a sine function and use a built-in variable called time, which is the time to start, and I multiply it by something big. Let's see what that does. So what we've done is saying take the incoming x coordinate and just apply this a little bit of math to it, okay? And what we should get, hopefully, is it moving left and right. Yes, there you go. So already we've got procedural animation going on. So there's no C# code, there's no JavaScript code moving this plane. And we can prove that again by going in there, clicking on it and seeing there's no script attached. Absolutely no script. The only thing we've supplied is a shader and a material, and yet it's moving. So what have we done? All we've done, we say inside here we've gone, affect the x coordinate of the vertices coming in by applying a sine wave to it, multiplied by this factor here. Okay, we can do the same thing to the y as well. So Let's add cos. Let's do it by the same amount in the time being. You'll see why the double brackets in a minute, because I'm going to do something else to it. But I'm now affecting the x and y coordinates of each of those points. See what happens. We're moving. Now we're getting a bit of depth here because we're in a 3D scene, but the thing is it'll work in a 2D scene as well, okay? Remember, we're looking down on this now, okay? So now we've got this thing moving, is all, animating away, nothing too complex admittedly, and it's all done through the shader. But let's make it a bit more funky. This is where the double brackets come in. So let's add in a per vertex information, say x in this case, and let's do it for y. So all we're saying is add a bit of an offset in there, which is the x position and the y position, to make it a bit more varied. And run that, and look what happens. It's a bit wobbly now, isn't it? It's a bit like a jello. Now the thing is, these are very basic shaders. It's just showing you what a shader can do. But you can do a lot more in there. Once you go into these in depth, you can start doing some very nifty procedural animation. In one particular game, for a few years in London, I did a procedural jellyfish moving around using code that didn't look that much different from this. But once you've done one shader, you can apply it to other things. So let's have a go at that. So let's take our plane, let's hide it, and let's add in a cube. Let's position it at 0. So where are we? Are you seeing it? Oh yeah, it's a bit too far away. So let's take our camera in a bit, shoot a bit more. Okay, let's take our camera a bit. No, the other way. Let's move it over. Or take this bar of Unity. Oh, there you go. Let's look. Which way are we going? That's better. So we should see a bit more of the 3D object there, okay? So we've got our cube. Again, it's the dull grey. Now, magic happens if we just go, let's apply our shader. What happens? Procedural animation yet again, okay? So there's no script attached to this. All we did was we took the shader we just created for the plane and applied it to a cube to see what would happen. Now, as you can see, some pretty wild stuff happened. And that, in a nutshell, is very basic introduction to shaders. I'll make this code available somewhere. I'll post a link into it. But if you haven't used shaders or haven't considered using shaders before, take a look at what they can do, read up a bit on them, and you'll get some powerful stuff out of it. See you later.